In this we do problem, we have a compound that has some carbon in it, hydrogen, and this time phosphorus. Again, empirical formula, and then we want to figure out what the molecular formula is. So hopefully you tried this one on your own. Let's see how you did. We're going to convert all of our percentages to moles by assuming we have 100 grams of the substance. So that means for carbon, 56.5% translates into 56.5 grams of carbon. And since we know the molar mass of carbon is about 12.01 grams, that gives us approximately 4.70 moles of carbon. For hydrogen, we have 7.11 grams of hydrogen, and 1 mole of hydrogen has a mass of 1.01 grams. That gives us about 7.04. These numbers are not super nice right now, but we'll make them nice. Hydrogen. And then for phosphorus, which is P, we have, let's see, 36.4 grams. And if we look at the periodic table, we can see that 1 mole of phosphorus has a mass of 30.97 grams. And that gives us about 1.18 moles of phosphorus, which is pretty close to 1, but not exactly. So we have carbon, which is some mole ratio to hydrogen, which is some mole ratio to phosphorus, which we're trying to figure out. So we want to make these numbers nice. So we're going to divide by the smallest number of moles, which happens to be the 1.18. So 1.18, 1.18, 1.18. So if we divide by the smallest number, that actually gives us some pretty decent numbers. This ends up being close to 4. This ends up being pretty close to 6, and of course this is 1. So now we can substitute our mole ratio as C4H6P, and that's going to be our empirical formula. So that's our EF, empirical formula. Now our empirical formula mass is, so empirical formula mass is approximately, let's see, 85.06 grams per mole. Now they're telling us that whatever this compound is, its molar mass should be about 170.14. So we're going to take our molecular formula mass, divide it by our empirical formula mass, and see what we get. So if we take 170.14 and we divide it by 85.06, we get approximately 2, which means that our molecular formula is going to be our empirical formula, C4H6P times 2, because its molar mass should be twice as heavy. So our molecular formula ends up being C8H12P2. And that is our molecular formula. That's it.